Welcome to this audio presentation. My name is Jianjun He. I'm from DSP Lab, Nanotechnological University, Singapore. In the next 5 minutes, I would like to present to you our conference paper that was presented at ICASSP2015 in Brisbane, Australia. The title of our paper is on the Preprocessing and Postprocessing of HRTF Individualization based on sparse representation of anthropometric features. In our daily life, humans can hear and understand the sound captured by the ears. From an acoustic point of view, the sound that reaches our eardrum has been filtered by our body, head, and most importantly the ear. Head-related transfer function HRTF is to describe the response of such filtering process. HRTFs contain sound localization cues and are commonly used in 3D audio reproduction, especially when using headphones. HRTFs are highly individualized and are closely related to our anthropometry. Therefore, anthropometry can often be used for HRTF individualization based on the database of the HRTF and the anthropometric features. In this paper, we aim to answer 3 questions. First, whether the pre-processing and post-processing methods on the HRTF and anthropometric database affect the performance of the HRTF individualization. Second, if so, what is the best pre-processing and post-processing combination? And third, how good is it? The current study was conducted based on the CPIC database that consists of 37 anthropometric features of 35 subjects and the corresponding HRTFs of 1,250 directions. Our definition of samples is as follows. A is the anthropometry database with S subjects. A1 is the anthropometry of a new person. H is the HRTF database with S subjects. H1 is the HRTF of the new person to be estimated. For HRTF individualization technique, we consider an approach proposed by Blinsky, Tashev, and so on recently that synthesizes HRTF via sparse representation of anthropometric features. First, they trained a sparse representation based on the anthropometric features and then apply this representation to the HRTF database to obtain the HRTF of the new person. Compared to other HRTF individualization techniques, this method can avoid the problem of anthropometric feature selection. Next, we introduce the pre-processing and post-processing methods at different stages of HRTF individualization, including pre-processing of anthropometry, 4 variants, pre-processing of HRTF, 3 variants, sparse representation, 2 variants, and post-processing of anthropometry, 2 variants, followed by the corresponding HRTF synthesis. In total, we have 48 variants of methods. To evaluate the performance of these methods, spectrum distortion (SD) averaged across 35 subjects and 1,250 directions is employed. The results of the 48 methods are illustrated in the figure below. We shall see that performance varies among different pre-processing and post-processing methods. More specifically, we observed that for direct sparse representation, pre-processing of anthropometry affects a lot, with standard deviation as the best. Log magnitude is the best pre-processing for HRTF, while post-processing has minimum effect. For non-negative sparse representation, we find it to be better than the corresponding direct sparse representation method. And the best performance is achieved by standard score anthropometry pre-processing, log magnitude HRTF pre-processing, non-negative sparse representation, and normalized anthropometry post-processing. Furthermore, we compare our best performance with some existing methods as well as the lower bound derived using the actual HRTFs, which indicates that our approach is already quite close to the lower bound. In conclusion, we studied different pre-processing and post-processing methods in HRTF individualization in this paper. Refer to the 3 questions that we asked in the beginning. We found that the pre-processing and post-processing methods do affect the performance of HRTF individualization, and also found that our best combination outperforms existing approaches and is quite close to the lower bound. Future work includes the subjective evaluation of these HRTF individualization techniques. The key references of our paper are listed here. For more details, please refer to our paper in ICASSP Proceeding or contact us directly. Thank you for watching.